Good day all, and well, I hope it's a prosperous new year to all of you. And I'm doing a recording here of a new tool that I've made. I must mention that there are many of tools on the web that you can get in terms of pumping and pumping specification, and many suppliers do provide this. I'm just giving this as an Excel tool that you can download just to help your understanding of how pumps work. And I'm going to be touching on the water pump calculations now. And the reason for that is, and I'll later do slurry pump calculations and show that in a later tool that will release. But this is just to help you get a bit of idea of how it works. So you can see I've got all the formulas here that are used, and there you can find the source. If you can click on that, you would be able to get to the source of those units. And now you can see, and once again, how shall I put it, the way my Excel sheets work is always the same, is that your inputs are typically on the blue values and the calculations are on the gray values. So here you've got the global inputs, which you put the static head in terms of how high do you want the pump to pump, the flow rate, the internal diameter of the pipe expressed in meters, and then the total length of the pipeline. Now what you can do is, you can see here basically these are how the calculations pull through, and here these are fittings that, if you imagine a pipeline and you had more fittings and valves, etc., the more there would be resistance to flow. Now what I've also got here, you can see fitting loss coefficient worksheet. You can see there is the fitting loss coefficient worksheet. So these are the values that you can pick, and then you can put them in the calculation sheet for these blue values, light blue, to get you an idea of the resistance to flow that each different type of fitting or whatever provides. Then the biggest contributor to resistance to flow is actually the length of the pipeline. And that's basically just because the pipelines often are very long, and then it just experiences resistance as it flows along the pipeline. Like if you were to think of your university studies of power lines, and the longer a wire is, the higher its resistance, and same in this case here. And you can see this is the pipe friction factor, which is a fraction of the friction coefficient, the length of the pipeline, and then also the diameter of the pipe. Now, and here you can see it's calculated the K value, but based on the roughness of the inside of the pipe. Now, what I've done here is I've also given you roughness coefficient, so you can go to look at the different materials a pipeline is made from. In this case, I've used stretched steel in the calculation here, and it's just to give you a starting point for the calculation, and then the kinematic viscosity. And I've got it also here, as you can see. There's the curve for water, and you would say what temperature am I at, and you read off that value, and remember that's a 1.00, and then you would times 10 to the power of -6, which is exactly what is being put in here if you look at the value over there. And basically what you do is that you would calculate also the efficiency. Now what you've got, if you've got those previous calculations, it comes from the previous worksheet, i.e. the pump head feed calculation. You've got the flow rate and the head. And basically you want to see what the efficiency of the pump is. Now in this case, if you go to 331 and you go here and you go to head of 37, which is more or less just below there, you'd see it's pretty damn close to this best efficiency point percentage here. And you would put that percentage in there, and that would calculate your power requirement for this pumping system. Now what I've got here is this graph here is specifically made the way like this is because each supplier for their different models, they have sheets. So you can, so this is a generic, there's no model number, etc. So what you do is you typically would approach a pump supplier and ask them for their pump curves, and you look up the different pumps based on the head and flow rate, and you see what efficiency point it is. Sometimes you might actually have at worse efficiency points, and then you put that value in there. But anyway, the point of this is just it gives you a taste of pump calculations, and my suggestion is you download it, use it, and then approach your various pump suppliers in the world to give you their pump curves. The way you can download this is at offer.ndme-inc.com. You can see there's the ndme-inc.com. So it's offer, you just put in offer.ndme-inc.com. And then you can download even my other freeware that I provide you to help you in your career as a metallurgist.